Hello friends, Mr. Burrell here. We're at the very end of our unit concerning right triangle trigonometry. We've talked about sine, cosine, and tangent and how to use sine, cosine, and tangent to solve for missing sides and angles of right triangles. We've also gone over some real-world examples of where you can use these different trigonometric functions in the real world to solve different kinds of problems. So we're going to end off talking about using trig functions and the Pythagorean theorem together. We have all these tools in our tool belt. We have the Pythagorean theorem, we have sine, cosine, and tangent. We're going to kind of mesh them together, talk about how we can use them together. So, by the end of this video, by the end of this lesson, these are the things that I hope you're able to do. I want you to be able to, given the fraction value for one trig function, find the other two. So if I give you the fraction value of sine, for example, the sine of some angle is equal to 5 over 12. If I give you just that, I want you to be able to find what the cosine and the tangent values are. Okay? So, as a review, I want us to find the missing sides of these two right triangles using the Pythagorean theorem. Okay, so in the Pythagorean theorem, if you remember correctly, the hypotenuse is C, and then I can label my short sides, the legs of this right triangle, as A and B. Which means in this first triangle, I'd have 8 squared plus 15 squared equals C squared. The Pythagorean theorem says A squared plus B squared equals C squared. Well, if I grab my handy-dandy calculator, 8 squared is 64, 15 squared is 225, and then 64 plus 225 is 289. And then in order to solve for that missing side, in order to solve for C, I have to square root 289, which gives me that side length being equal to 17. So this side right here would be 17. Cool. On this right triangle, I could kind of label them a similar way. The hypotenuse is C, the legs are A and B. So if I go A squared plus B squared equals C squared, filling in 24 for B and 25 for C. Let me do some math here. I have A squared plus 576 equals 625. Well, to get A squared by itself, I have to subtract 576 on both sides, which gives me A squared equals 49. So then, since that's A squared, I square root that and end up with A equals 17. So this side over here is 7. Wow, not 17. The square root of 49 is 7 would be that missing side. That's something we already know how to do. Okay, that's something we already know how to do. So, I have these same triangles. This side was 17, this side was 7. So now knowing what we know about our trig ratios, we're going to work with that. We're going to work with what we know with the Pythagorean theorem and these trig ratios together. So, for example, in this first problem here, it says, if the cosine of x is equal to 8 over 17, what is the sine of x? So cosine of x is 8 over 17. So let me just label this triangle real quick. Say I'm looking at this angle, or sorry, not this angle, this angle right here. If I were to label my sides in this triangle, this would be the opposite side, this would be the adjacent side, this would be the hypotenuse side. So, cosine of that angle, call this x, the cosine of that angle, would be adjacent over hypotenuse. That's what my SOHCAHTOA reminds me of. But the cosine of this angle would be adjacent over hypotenuse, or in this case, 8 over 17. Right? Okay. So I have this right triangle. I know the adjacent side is 8. I know the hypotenuse side is 17. So then it says, if that's the case, what is the sine of angle x? Well, in this same triangle, the sine of angle x, sine is equal to opposite over hypotenuse. So that would be 15 over 17. So knowing that this triangle, I have this triangle where the cosine is 8 over 17, that means that the sine of that same angle in that same triangle would be 15 over 17. Okay. Feel good about that? Okay, then in this second one, this should be a 7. I don't know why it's a 5. This should be a 7. If tangent of x is 7 over 24, what is the sine of x? So now if you look at this triangle, say I'm looking at this angle right here, call it x, this would be my opposite, adjacent, and hypotenuse sides. So you notice that indeed the tangent of that angle is opposite over adjacent. That's what the TOA part of SOHCAHTOA tells me. Opposite over adjacent, which is 7 over 24. So in that triangle where the tangent is 7 over 24, what is the sine of angle x? Well, if this is angle x, sine is going to be opposite over hypotenuse, which was 7 over 25. Okay? So knowing all these sides of the right triangle, if I have one of the trig ratios, say tangent, I can use what I know about sine, cosine, and tangent in the Pythagorean theorem to find this other ratio, say sine. Okay? Well, what about these? So if I tell you that cosine of x is 3 over 5, and I want to find what the tangent of x is, how do I go about doing that? Well, first, I would recommend drawing some triangles. So I have some triangles drawn for us right now. I have 2 right triangles. And I'm going to label an angle here. Say I'm looking at this angle. That would mean this is my opposite side, my adjacent side, and my, hypotenuse side. So cosine of x is equal to 3 over 5. Call this x. Cosine of x is equal to 3 over 5. Well, cosine, if I reflect back to SOHCAHTOA, cosine is adjacent over hypotenuse. So my adjacent side would be 3, and my hypotenuse side would be 5. Okay, my adjacent side would be 3, my hypotenuse side would be 5. That's cool and dandy. That I know those sides in this right triangle based on what I know about cosine. Well, what it's asking me for here, it's asking me for what the tangent of angle x is. Well, tangent is opposite over adjacent. Opposite over adjacent. Well, shoot. I don't know what that opposite side is. But since I know the other 2 sides of this right triangle, let me change these opposite, hypotenuse, adjacent. Since I know the other 2 sides of this right triangle, I can find that third side using the Pythagorean theorem. So call this A, B, and C. The Pythagorean theorem says a squared plus b squared equals c squared. I can find that third side with the Pythagorean theorem. Let's do it. So it would be a squared plus b squared equals c squared, or a squared plus 3 squared equals 5 squared. We just did this. We just reviewed these kinds of problems. So this would be a squared plus 9 equals 25. I have to subtract 9 on both sides, which gives me a squared equals 16. When I square root 16, I get a equals 4. So that's the third side of this right triangle. 3, 4, and 5 are the sides of this right triangle. Well, now if I'm coming back to the question I was actually being asked, I wanted what the tangent of x was, or opposite over adjacent. Well, I just found the opposite side, it's 4, and the adjacent side I already knew, it was 3, so the tangent of x is 4 over 3. And that's it. Tangent of x is 4 over 3. Okay, let's do another example. So, I'm going to label this triangle for question number 4 here. So it says, if sine of x is 5 over 13, what is the cosine of x? If sine of x is 5 over 13, what is the cosine of x? Okay. Well, in these right triangles, I always start off by labeling the sides. So if this is the angle I'm looking at, call it x. This is the hypotenuse. This is the opposite. This is the adjacent. Okay. Adjacent. Well, sine of x, sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So that means in this right triangle, the opposite side is 5. The hypotenuse side is 13. Cool, great. I can figure that stuff out. I can label some of the stuff in this right triangle based on that trig ratio that I'm given. Sine is equal to 5 over 13. So then what's the cosine of x? Well, according to SOHCAHTOA, cosine again is adjacent over hypotenuse. Adjacent over hypotenuse. Well, shoot! I don't know the adjacent side, right? I don't know the adjacent side. But because I know the other two sides of this right triangle, call this A, B, and C, I can use the Pythagorean theorem to find that missing side. So using the Pythagorean theorem, this would be 5 squared plus b squared equals 13 squared, which comes out to 25 plus b squared equals 169. I would have to subtract 25 on both sides, which would give me b squared equals, I believe that's 144. And then I'd have to square root both of those. And the square root of 144 would give me b equals 12. So this missing side here would be 12. Well, now that I know all the sides of this right triangle, cosine of x, being adjacent over hypotenuse, is going to be 12 over 13. So those are going to be 12 over 13. That's what the cosine of x is. So I'll give you a chance to try out these problems right here. I'm not going to do them together. You can pause this and experiment with these. Know that you will want to draw your own triangle. Label one of the angles as x. Label the sides. And then you'll want to determine what sides these numbers are going to go on so you can figure out what the tangent is. Note that some of these will end up being decimals, which is completely fine. So, that's all I've got for you. That is all I have for you today. Given the fraction of one value for a trig function, I hope that you can now use the Pythagorean theorem to find the other two. So hopefully if I were to give you one value of a trig function, you would be able to use that alongside the Pythagorean theorem to find the other trig functions. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. Please let me know. And I hope that you enjoyed that as much as I did.